All right, open your books to page 256.
200.
What comes next?
And have your homework out on
And have your homework out on your desk.
Clear your desk, prepare for a quiz.
Clear your desk.
No.
Michael's predictive text loses something there. Page 256 in your books. Numbers 2, 8, and 10 you had for homework. Have those graphs out, and let's take a look at those. Number 2 was fairly straightforward. You had two linear inequalities that you needed to graph together in a system. Of course, when you graph an inequality, it's not just a line that you're graphing. Rather, class, you're graphing a line and then also shading in one side of that line. Same thing here. But in a system, you've got two separate shadings. We're looking for the region where the shadings overlap each other. Good. So on our first equation, or inequality rather, here we had x plus 2y is greater than 10. I'm actually going to go with the intercept method here to graph. So the x-intercept, if we plug a 0 in for the y, would be a 10, which is just obnoxious. And then the y-intercept is going to be a 5. When I draw my line, how should I draw it, class? As a dashed line or a dotted line. And so we'll do that as well. Of course, we could do slope-intercept form as well, but you know, it was easier to do intercepts than I had this. Oh boy, the next one's not going to be, though. The next one I'm going to do slope-intercept form. So we do it dashed line. And again, that's part of it, but we also have to get the shading. To figure out where to shade, what should I do, Audrey?
You plug 0 into the x and y.
Good, we're testing 0, 0, the origin, which happens to be 0 for x and 0 for y, and we see if it's true. Is it true that 0 plus 0 is greater than 10? No, it's a lie. So we're not going to shade where the origin is, because that's a lie. We're going to shade the other side of the boundary, which is everything up here. That's the solution to the first inequality. How many had that on number 2 for your first one? Then for the second part here, I am going to go slope-intercept form because I don't want an intercept of 15. And so we'll say 3y is greater than x minus 15. Divide everything by the 3. Y is greater than a third x minus 5. That's going to be a lot easier. We'll do the negative 5. We'll rise 1, run 3. And shade that, or draw that as a class dotted line. And that's what I have for my second line. Are we good with that? I heard a noise that made me think, did I just do something wrong? Okay, so we're good with that. Now the hard part is, if we shade above, all of this stuff still wouldn't get shaded. It would just be this region. If we shade below, well, until we come up above this line here, this is where the shaded region would be. Let's see what we've got. Try a 0, 0 in here. Is 0 bigger than negative 15, class? Okay, so everything above this line satisfies the next inequality, but it doesn't matter if it's above this line if it's not also above this one. So the region that's above and above, which would start here, all of this is going to be our solution here, above both lines. And how many found that region to be your final solution? Okay, only a couple of you. Questions?
When I graphed, I had slope-intercept form for the first one, but I had a positive 5, but I graphed it as a negative 5.
I gotcha. Okay, so yeah, let me show the slope-intercept form real quick here. Y is greater than negative a half x plus 5. So 5, rise 1, run 2. So there's your line.
So I had close to that shading area, but I did negative 1/3 x for the second equation.
So when you move the x over, forgot to change it to a positive. So you rose and ran this way. So you ended up with a line that would have like almost run, not parallel, but close to parallel, enough that it would have been really obnoxious. Okay, questions? Let's take a look at the next one, number 8. And for this one, we had 3 linear equations. So presumably looking for a triangle to be formed by these 3 lines. We have a negative 12x plus 3y is less than or equal to 24. We had a 4x positive 5y is less than 40, and y is greater than 4. Let's shut that up. All right. And let's go ahead and... yeah. What? That's okay. The supervisor just excused it, so we're good. All right, y is greater than 4. Y is greater than 4. What does that line look like, first of all, the boundary line? Horizontal line through 4. In this case, a dashed line through the 4, and greater than 4 means everything that is above it. Right? So this is my first shaded region. Again, that's probably going to get narrowed down considerably by the time we do the next couple of lines. If I were to go intercepts here, plug a 0 in for the y, I would get a 10. Plug a 0 in for the x, I'd get an 8. So 10, 0, 3, 6, 9, 10, and then 0, 8, 3, 4, 8. There we go. And so we connect those two dots, again with a dashed line. Looking for ruler. And for this one, we're going to have to plug in the origin. Does the origin work, class?
No.
0 plus 0 is smaller than 40?
Yes.
Yeah. So the origin works. So everything below the line would work, right? Except it still has to be above this. So now we're down to this region here. Do you see that? Above the one line, below the other line. And then we've got one more line to put here. Again, if I went intercepts, just because we hadn't done that in a while, plug in a 0, get -2. Plug in a 0, get 8. -2, 0. And 0, 8's the same point again. We'll draw that line. Oh, that's a solid line. Excuse me. Solid line. And then we plug in 0, 0 again. Does 0, 0 work, class? Yes, 0 plus 0 is less than 24. So that means everything to this side, but it's supposed to be below the line, it's supposed to be above that line. So we really just get this very little triangle as our area with a solid line on one side, and then the other boundary lines are not as part of the solution. How many have that little triangle for number 8? Okay, several of you that time. Questions from those who didn't. And then the fun one with the quadratic on number 10, I believe it was. And for number 10, we had a y is greater than x squared -7. I'm okay there. And then y is less than x minus 1. All right, let's start with the parabola. Only one change to my parabola, class. I shifted down 7. But it's still going to go up. It's still going to be over 1, up 1, and so forth. So down 7. Over 1 up, 1 over 1 up, 3 over 1 up, 5. I may have to do over 1 up 7. Yep, because I have room for it. All right, so dashed line. Okay, so something like that. Let's try the origin, see if a 0, 0 works. Does it work, class? Yeah, 0 is greater than 0 minus 7, or 0 is bigger than -7. So everything in here preliminarily is shaded. Let's run the line here as well. Already in slope-intercept form, class, y-intercept? -1. Slope? 1 over 1. Rise 1, run 1. So we're going to put a line here. Dashed line again. I'll do it free-handed here. Oh, should have done it free-handed. That's what I get. Yeah, I'm 1 over. All right, and then does 0, 0 check here? No, so we're not going to shade above the line. So not this portion of the parabola, but just this portion here. And how many had that little bottom of the parabola shaded in? Okay, several of you, those who didn't, questions. All right, questions at all on graphing inequalities or systems of inequalities? Michael, what's my line? What's my line?
Your line.
What's my line?
You lose some, you lose some.
That's actually a good prediction. Yeah. What's the other line?
Do not prepare for this. It's not time for a quiz.
You're right, it isn't. I'm actually not going to test or quiz you on this stuff, but I wanted to show it to you anyway, so you don't have to worry about that. Let's move on to something you will be tested and quizzed on, and those are matrices. Genesis is about to have a panic attack. No, if I were gonna test you and quiz you on this, we just spent a little bit more time practicing it. But since I'm not testing and quizzing you on these, we will move on. I asked you to read over pages 270 to 274 for your homework last night. Read about things called matrices. We're going to kind of go through and explain what the book was trying to explain to you. Hopefully I will make more sense than the book, since those who said that you read, my good diligent students should, sounded terrified still. All right, so I want to kind of build on this system of equations I do, right? If I had something like 3x minus 2y equals 5 and x plus 4y is equal to 7, for instance, as a system of equations. We don't really do anything with the x or y, right? The x and y are there so that we can line things up, but really everything we do is with the coefficients, isn't it? We multiply the top by a 2 to make the -4 and the +4 inverses, and then everything's with the numbers. The x and y just kind of are along for the ride, aren't they? So to a mathematician who is lazy, why would I write the x's and y's if I ain't gotta? Why not just work with the numbers and maybe write a 3 and a -2 and a 1 and a +4 and just make a little set of numbers like that, and maybe say that that is equal to a little set of numbers like 5 and 7. I don't have to write all the x's and y's now. You can see where if you had multiple equations with multiple unknowns, that could really save you a lot of time. All those x's and y's, you ain't got to write no more. That's a matrix. A matrix is simply an organized collection of numbers here. So here's your definition. Next term in your notes is a matrix. A matrix is an arrangement of numbers in rows and columns. An arrangement of numbers in rows and columns. A little later on, as we get through our discussion of matrices, I'll come back to how you'd actually solve a system of equations using a matrix. We're not there yet. Today's just an introduction to what a matrix is. It's an arrangement of numbers in rows and columns. Now, how do we define the size of a matrix? The size of a matrix. Write this in your notes if you would. It's defined as the number of rows by the number of columns. The number of rows by the number of columns. A matrix is defined as the number of rows by the number of columns. For instance, this matrix here has 2 rows. It also has 2 columns. We would call this a 2 by 2 matrix. This little matrix here has 2 rows. It has 1 column. This would be a 2 by 1 matrix. Okay? Number of rows by number of columns. And that's how we define the size of a matrix. If I had this matrix, maybe a 2, -2, a 3, a 0, a 4, a 5, a -6, a 1, and a 12. What would be the size of this matrix, Kendall?
2 by 4.
It's a 2 by 4. 2 by 4 matrix. 2 rows, 4 columns. Easy enough? That's going to be important with what we're going to get to in just a moment to be able to identify the size of a matrix. Next term for you to write down is the term element. This is not like in chemistry. An element is a single value in a matrix. Every value is referred to as an element. If I were to name this matrix, matrix A, we, by the way, would use capital letters to name a matrix. Okay, so if I wanted to name the matrix, I could put capital letter A right there. Okay, matrix A. This is my first element in the first row. We would notate that position A11, row 1, column 1. This next is element A12. Matrix A, using a lowercase for the element, capital for the name, row 1, column 2. What would this be, class? A13. This would be A14. This would be A21. Row 2, column 1. This would be A22. Okay, not A22, but A22. This would be A23. This would be A24. Okay? And again, if this had been called matrix G, for instance, then it would be G11, G12, G. You get the idea. So every element has a specific name based on its location in the matrix. Where is it located? If you have something called a row matrix, A row matrix, that is a matrix that consists of a single row. For instance, 3, 2, -7. That'd be considered a row matrix. It happens to be a 1 by 3. But because it only consists of a single row, it is a row matrix. Make sense? If we have something called a column matrix, anyone want to guess what that would be? A matrix that is a single column. This, a 2 by 1 matrix specifically, but this would be called a column matrix because it's a single column. Here's one for you. A matrix that is a single column is a column matrix. What about a square matrix?
2 rows, 2 columns.
Possibly. Or 3 rows, 3 columns. Or 12 rows, 12 columns. Hopefully you don't have to write that. Right. A square matrix is simply a matrix with an equal number of rows and columns. A square matrix is a matrix with an equal number of rows and columns. This, for instance, is a square matrix. It has 2 rows and 2 columns. But if it had 5 rows and 5 columns, that would also be a square matrix. Make sense? So, what do we call any arrangement of numbers in rows and columns, class? Matrix. What do we call the vertical arrangements of numbers in the matrix? Columns. And the horizontal arrangements are called rows. Obviously, if you're familiar with computers and Excel, for instance, rows and columns, that's all coming back. If we define the size of the matrix, it's the 2 values, the number of rows, then the number of columns. Again, that's going to be very important with where we're going later, so make sure we're good to go with that. Every value in a matrix is called an element. Good. If a matrix consists of a single column. Column matrix. If it consists of a single row, row matrix. If they have the same number of rows and columns, square matrix. Look at page 271. Page 271. I believe you're already there. I am not. So let me go ahead and get there. Page 271. And look at the example problem. Example 6.1a. It says identify the appropriate element from the given matrices. Now notice they've named these matrices. There's matrix A, matrix B, and matrix C. They ask first of all for element B, 2, 4. Well, first of all, class, which matrix should we look at? B. And then we should go to row, column 4. And we see that the 0 is there. Look at the next thing. Element A, 2, 1. That means we need to go to matrix A, row, column, and there's the -2. For C3, 2, we need to go to matrix C, row 3, column 2, and there you see the 4. Does that seem pretty easy? Not blowing anyone's brain yet, right? So like I said, I know you might be terrified of what's coming, but at least for right now, we're still good. Maddie, you okay? All right, good. All right, page 274. We're gonna take it slow, okay? I'm gonna try to not blow your brain here. Page 274. I want you to do numbers 1 through 4. They've given you a matrix. You identify the appropriate elements on 1 through 4 on page 274. This has nothing to do with the movie, by the way. So if you're like, when does the movie come in? It doesn't. Sorry. Math class is boring again. I'm sorry.
We should watch the movie.
Don't they have like the numbers and all that?
Yeah, they have numbers.
Yeah.
Really?
Yeah.
Work on 1 through 4. You done?
Yeah.
This is too easy. People of your intellect should not be doing problems this easy, huh?
I'm fine with it.
4 matrices.
All right, Brandon, first of all, what are the dimensions of the matrix?
Row 1.
No, what are the dimensions of the matrix?
3 by 3.
Yeah, it's a 3 by 3 matrix, right? So, because it has the same number of rows and columns, class, we would call this a square matrix. What is the name of the matrix, Abby?
The square matrix?
And what is the name of the matrix?
A.
A, for Abby. See? All right, so what is element A13? Audrey. 2. What is element A23? Genesis. What is element 8? That's -8 for those watching on YouTube. Number 3, Michael. A31 is 19. And then A21 is what, Kendall? 4. How many got all 4 of those right? All right, so we're good so far. Good. All right, now, up the ante on you here. 5 through 8, they've already told you certain numbers. You need to tell what is the element name for these different numbers. So do 5 through 8 at your seats. All right, so number 5, negative 17 is which element? Maddie? B, 3, 2. By the way, notice we subnotate the 3, 2, so it's a little lowercase b with the little 3, 2 written below it. Number 6, the 33 is which element, Abby?
B, 2, 3.
What about the negative 42? Brandon?
B, 3, 1.
What about the 12? Audrey?
A, 1, 3.
But it's not A13, is it? Genesis?
B,
1. B13, because it's matrix B. It's like, but I like A better. A for Audrey. I'm sorry. All right. Questions on this? So far, so good. All right. So we're going to move on to something that actually requires math. Okay? But brace yourself. Next thing you know is adding matrices. Adding matrices. By the way, in case you haven't picked up on it, matrix is singular, matrices is plural. 1 matrix, 2 matrices. Adding matrices. First of all, first thing to write down, matrices must be of equal size in order to add them. Just as you can't add whatever you want in algebra, right? They have to be like terms if you're dealing with polynomials. So with matrices, they must be of equal size. A 3 by 4 matrix can only be added to another 3 by 4 matrix. A 5 by 8 matrix could only be added to a 5 by 8 matrix. A 3 by 1 matrix could only be added to another 3 by 1 matrix. By the way, what would we call a 3 by 1 matrix? A column matrix, right? 3 rows, 1 column, so it'd be called a column matrix. Anyway, how do we add or subtract matrices? You add or subtract, add typically, subtraction is adding the inverse, but we add corresponding elements. We simply add corresponding elements. So 2 things to add matrices. First of all, they must be equal size. And then what do? We add or subtract, add the inverse. So we'll just say add. We add corresponding elements. So if you'll turn back to page 272. Flip back to page 272. Look at example 6.1b. Do you see there are 3 matrices? All of the matrices, class, are what dimensions? 2 by 2. So they're all 2 by 2 square matrices. That's important because if they weren't, you could not add them. They must be equal size. They don't necessarily have to be square, but they do have to be equal size. And they all are. They're all 2 by 2. Notice there's parentheses. Now, they're really stretched out parentheses. But do you see the parentheses around the 2nd and 3rd matrices? We always do parentheses first, right? We still follow order of operations. It's still algebra class. So notice what they did. Actually, you know what? Let's do this the easy way, okay? Because there's a much easier way to do this than the way they show everything. Sometimes you can show too much. And I think they showed too much. For you all to be saying that this looks scary. All right, so we're going to add what's in the parentheses first. When we say add corresponding elements, these are both the 1, 1 elements, correct? For whatever their names are, which aren't specified, those are 1, 1s. So we're going to add them. Add the 5 and the 2. Add the 0 and the 2. Add the negative 1 and negative 2. Add the 3 and the negative 7. We're done with that addition. Now that we've solved the parentheses, we can add the sum to this matrix, which again is of the same size. We add the corresponding elements here, then here, then here, and then here. And we're done. Just like that. Still seem easy. Okay? Does it look that easy in the book? No. Probably not, but it's really that easy, okay? Look at example C. they give you a 0, 3, 2, 2, negative 1, 4, 5, 4, negative 3. And that's, it says to subtract. Do we ever really subtract, class? We add the inverse. So I'm actually going to change this to adding, and by inverse we mean inverse of everything. So instead of writing 3, 1, 4, negative 3, negative 1, negative 4, how should I write the next row in the matrix, Audrey?
Positive 7, negative 10.
Good. And what about the next row in the matrix, Genesis?
4, negative 2.
Good. Okay, so we don't subtract, we add the inverse. If it says subtract, change it to adding the inverse. Then we add. What do I get for my top row in my resulting 3 by 3 matrix? Maddie? Good. Just add, add, add. All right, then for the next row, what do I get, Kendall?
Negative 3, 6, and negative 6.
And then the final row, Michael.
9 and 2 and negative 11.
You cheated and looked in your book. I'm just kidding. You did. All right, and there's our answer. Do we see how easy adding matrices can be? Seem easy? Feel easy? Good. Turn over to page 274 again. Do numbers 9 and 11. Do numbers 9 and 11. Add the matrices. I wouldn't recommend copying it into your notes. I would just do it in your head because it takes a long time to copy everything. That's just me. You might be able to squeeze the answers in your book, though it's kind of a tight squeeze there, but you know. Wrong. All right, number 9. Let's go to Brandon. Brandon, what was your answer to that addition problem?
Negative 4, 4, 7, 19.
Very good. Negative 4, 4, 7, 19. How many had that for number 9? Good. Number 11 is a big one. A 3 by 3 added to another 3 by 3. And do you have it now? If you were doing the last thing. I was about to call on you. I was like, oh, she's still working. What did you get, Genesis?
Oh, okay. 4, negative 21, 20, 32, negative 12, negative 25, 8, 14, 3. No, 20.
Really close on that next to last one, element, whatever the letter is, but element 32 would be negative 14. All right, so let's go through the answer again in case you couldn't hear. That's 4, negative 21, 20, 32, negative 12, negative 25, 8, negative 14, 20. How many had that for number 11? All right, questions on adding matrices. Look at the next page. Number 13 says to write the additive inverse. Okay, what this means is if you changed all the signs. That's the additive inverse. Okay? Now, the reason we emphasize this is later you're going to come across something called a multiplicative inverse. That's different. An additive inverse is literally just change all the signs. So, without even doing it, or if you decide to do it right there in your book, what is the additive inverse of matrix A in number 13? Abby?
Negative 2, 3, negative 46, negative 15, 16, 23, 1, 52.
I'm not going to insult your intelligence on YouTube by repeating the answer. Change all the signs. All right, we got that? So, on numbers 15 and 17, when it says to subtract, do we really subtract, class? No. I would do right there in your book, I would change it to adding the additive inverse of each of those. And then solve. Do 15 and 17 at your seats. You and want to add this to your notes, you could, though I don't think you're going to forget. But to subtract, add the additive inverse. Again, just like in regular algebra, only the one after the minus sign gets changed, right? Not one before the minus sign, but only after the minus sign gets changed.
What numbers did you say?
15 and 17, sorry.
Oh.
Finished? Do you feel slightly insulted by how easy this is?
No, I like it.
You like it? Okay. Just making sure. You're like, man, and I thought this was going to be like really cool mathy stuff. And it's just like easy stuff. Okay, as long as you're not offended. But I'm almost a senior. I should be able to do Now, I will say this, they've been nice, and everything they've given you has already been equal size, equal size, equal size. You know, it'd be really mean is if they gave you one where they weren't equal size and asked you to add or subtract them, and you'd have to be able to put not able to be solved.
You should do that on a quiz.
I should do that on a quiz or something.
To try to confuse us.
Put different sizes on there and see if it messes with your mind.
Exactly.
Just this gives you a look of death. All right, number 15, Maddie, what did you get?
20,
Good, 20, negative 29, negative 8, negative 11. And number 17, what did you get for your answer, Kendall?
negative 9, 61, negative 13, 61, 7, 8, negative 39, negative 51, negative 3.
Good. Negative 9, 61, negative 13, 61, 7, 8, negative 39, negative 51, negative 3 are our answers. And we got both of those correct. Again, you're thankful for all those math skills you developed when you were in elementary school, right? Very thankful for that. Now, next thing in your notes, since we seem to have this down pretty well, I feel like we can move on to the next thing. Scalar multiplication. Scalar multiplication. It sounds weird and hard. A scalar is simply a single constant that is multiplied by a matrix. A scalar is the name for a constant that is multiplied by a matrix. Well, to multiply by the scalar, you simply distribute to every element. Distribute to every element. So if you turn back in your books to page 273. Page 273. You see a 3 by 3 matrix, and it says to multiply the matrix by the scalar. Well, you see that in front of the matrix is the number 3. That's the scalar coefficient. We distribute the 3 to everything. So look at the original problem, skip the annoying work that they show, just go right down below it to the answer. Do you see how the 3 was distributed to get negative 3, 15, 18? 9, 3, negative 12? 12, negative 6, 9? Questions on what they did in example 6.1d? Does that seem really easy? It's like a multiplication box when you were in junior high. Remember the speed drills you used to do? Multiplication? Yeah, that's kind of what it is. It's a multiplication box. It's like, oh boy, speed drills. All right, so I want you now to do 19 and 21 on page 275. 19 and 21 on page 275. Pastor Adam addressing his fan club. Kids love him, right, Michael?
Apparently.
Must be a special affection they have for older people. Right? All right, number 19. Audrey, what did you get for your answer?
Negative 42, negative 18, 72, negative 54.
Good. Negative 42, negative 18. Positive 72, negative 54. How many had that for 19? Good. Number 21. Michael, what'd you get?
Negative 3, negative 12, 27, 6, 15, negative 36, negative 24, negative 42, 18.
Good. How many had the same answer? Just in case you couldn't hear it on the video, negative 3, negative 12, 27. 6, 15, negative 36, negative 24, negative 42, 18. Should be good to go there. Questions on that? All right. Flip back to page 273. Notice they give, in the bottom example, 3 matrices. Matrix A, matrix B, matrix C. Again, all of these are of equal size. They happen to all be square matrices. Again, don't get the idea that you have to have square matrices to add, subtract, or multiply by a scalar. They just happen to use square matrices. They are perhaps the most common. But anyway, they want, look at letter A, 3A minus 2B. You see it? Well, what that means is we need to multiply 3 by matrix A, multiply 2 by matrix B, and subtract. Or 3 times matrix A and negative 2 times matrix B, and then you can add them. But we follow order of operations. Multiplication happens before addition or subtraction. Make sense? So, for instance, if I want to do 3 times matrix A, well, looking at matrix A, let's do it in our heads here. Kendall, what do we get when we distribute a 3 through matrix A?
6, 18, 9, 9, 15, 0, negative 3, 0, 4.
All right, and then let's distribute a negative 2 through matrix B. What do we get there, Audrey?
6, negative 4, negative 2, 0, negative 10, 14, negative 14, negative 8, negative 6, 4.
All right, and because we distributed the negative 2, we get to add, which makes life easier. So when we add the matrices now, Abby, what do we get?
12, 14, 7, can't see, 9, 5, negative 14, and negative 11, negative 6, 16.
There we go. And we're done. Does that seem pretty easy? Look at the next page. Here they wanted 2b plus c minus a. 2b plus c minus a. Well, what are we going to have to do first if we follow order of operations, Maddie? Good. Add b plus c together. So flip back to the previous page where you can see b and c. And let's go ahead and add b and c together, Maddie.
2, negative 1.
Careful. Just one.
Negative 6. Negative 2. 2. 11. And then 8. 11. 24.
Good. And then it says minus a. Well, I'm not going to waste my time writing a just to subtract it, right? So if we're going to copy a, let's copy it down as the inverse. Genesis.
Negative 2, negative 8, 6,
Negative 6.
3, negative 3,
Negative 3. We're doing the inverse here.
negative 3, negative 5, 0, positive 1, 0, negative 3.
There we go. So I added b plus c, and I went ahead and took the liberty of changing it to a positive inverse here, adding an inverse. Next, what needs to happen? Order of operations. Brandon?
Multiply the 2.
Yeah, multiply the scalar here to get
4, 2, negative 12, 4, 4, 22, 16, 22, negative 8.
And we're going going to take this and add it to that. I'm too lazy to recopy that. So let's just add them together here. And what do we get for our final answer, Abby?
2, -4, -15, 1, -1, 22, 17, 22, and -12.
Perfect. Seem really easy. Even when they do things like parentheses and multiplying, we'll add first, then do the other, rather than distributing or anything like that. Adding the inverse, all of it in one problem, still not bad. Would we agree? So far, still nothing scary about matrices? We still feel okay about it? Let's try a couple kind of like this. Do number 23 on page 275. Do number 23 on page 275. 4c minus 2a. 4c minus 2a. Number 23. Brandon has an answer for 4c minus 2a. Abby has an answer. Audrey has an answer. We're going in order around the room here. Genesis, you're next. Okay, Genesis is next. Okay, Michael's turn.
Yeah.
Oh, you are done.
Yeah.
What?
I just
What?
finished right now.
Oh, okay.
Just now.
Just making sure. Okay,
I was
now,
just-
so let's see. Now it's Kendall's turn.
Checking.
Kendall done? And then Maddie gets to finish. Maddie, I'm sorry we had to make you last. It's our fault.
Sorry.
He started it.
Started it.
Shoot, Maddie finished first. Brandon would have had to be last.
That's fine.
Nope, Abby would have had to be last. All right. So Brandon, what did you get?
-82, -26, -12, -34, -36, 26, 4, 84, -28.
Really close. I just had a different element to 1.
I have 24.
That was also not what I had.
Oh.
Audrey, what was your element to 1?
-24.
I had a -24 right there. Everything else I had the same. So my answer was -82, -26, -12, -24, -36, 26, 4, 84, -28. How many had that answer? Literally everyone but my first 2 people that I called on. All right. Okay. Questions? Did we figure out where a mistake was made on that element? Just missed the negative. Okay.
I just put 3. I don't know why it said 34.
Mm-hmm.
I didn't have 24. I meant 24.
All right. Do we need to go over the steps of the 4c and the -2a?
Maybe we no.
You sure?
Yeah.
Okay. All right. Do number 25. -2 quantity a plus c. -2 quantity a plus c. Number 25. And Brandon's like, the rest of them didn't really get it. They just all raised their hands that they did because you got called on them. Maybe. Call one of them next time. How about that? Yeah, then I'll raise my hand that I got it too. first again.
Mm.
Abby's second again. Uh-oh, I see what's happening here.
I had the right numbers the first time.
Audrey's third again.
Oh my god.
Come on, Jesus.
Michael, don't ruin it. I had the right numbers. It's at 34.
We believe you. It's okay. We believe you. Really.
16 and negative 40.
Yeah. That would be negative 24. So yeah.
I just forgot to write the negative. I did say 24.
You did say 24. Okay, their Genesis is finished.
Oh, I finished.
It's our fault.
It is your fault.
All right, we're going to go to Maddie this time for her answer. Maddie, what did you get for negative 2, quantity A plus C?
15, negative 24, negative 12, negative 48, 42, negative 16, negative 2, negative 12, 2.
I was really close. I got a different element A1, 2. Kendall?
Negative 20.
I had a negative 20 right there. So I had 50, negative 20, negative 12, negative 48, 42, negative 16, negative 2, negative 12, positive 2. How many had that answer? Brandon's like, yeah, me, I got it. Questions on 25. Questions on 25. As long as I get all the rhymes right, you don't call. Brecken and Gavin are like, we get them all right too. We can even take pictures of our paper and show you.
Yeah.
We'll just wait for us to read off our answers.
Questions on this? All right, so day 1 of matrices. Not as scared anymore? She's still skeptical. She's skeptical. She sees that poster, she's like, But you looked at the example problems and thought, oh no, too. And the example problems really were pretty easy. You just didn't know what you were looking at. You just needed me to teach you what to look at. Anyway, no homework this evening. We will work on matrices more in our next lesson. Have a wonderful, truly wonderful rest of your day. Go Crusaders. Or go Genesis.